The history of alchemy. Chemistry comes from the word alchemy. Alchemy comes from the Arabic word for philosopher's stone. Alchemy arose independently in many areas of the world, all at the same time. It was man's first grand attempt to understand the universe and his place in it. Evidence of alchemy has been found that dates as far back as 600 BC in China, Greece, and Mesopotamia. Writings of ancient Greek philosophers like Pythagoras, Socrates, Democritus, Plato, and Aristotle all reflected and fueled many of the alchemistic beliefs. Later, alchemy spread throughout Asia and Europe and into Africa. Alchemy was a combination of science, art, philosophy, and religion. It united the practical with the mystical in a search for ultimate truth, power, and perfection. In this search, the masters taught apprentices about mining and purifying metals, working with glass and dyes, and extracting medicines from plants to cure diseases. Alchemists believed in the circle and creation of life. They believed in a universal intelligent spirit that governed all of creation. Matter and spirit, including the elements, metals, and humans, are all transmutable parts of a whole existence. Within the macrocosm of this creator or spirit lay the universe. Within this, the earth and all its polar microcosms. And the serpent eating its tail is the Ouroboros. It's the symbol of eternity and regeneration, which is a common emblem in alchemy. Alchemists believed that all things were composed of various proportions of the same essences. Earth, air, fire, and water were considered to be the four basic elements that made up everything in creation. Varying portions of each of these four elements made up everything that you could think of. You also see down here some alchemistic symbols for different metals that they worked with on a regular basis. Many of these symbols are still being used today. This is an allegorical engraving from 1599 or so. It depicts the alchemist in the center. He's surrounded by the symbols of his knowledge of the different spheres of his existence. The alchemist's goal was to prove that the universal spirit physically existed. That universal spirit was known as the prima materia, or core of all life. The prima materia was the source of all possible transmutations, including birth, growth, death, and rebirth or reconstitution. Proof of the existence of the universal spirit through the purification and transformation of metals into gold and silver was a common goal. The philosopher's stone was believed to be a special catalyst that could transform the prima materia into its physical form, thus allowing the alchemists to govern life itself. Most alchemists work for the wealthy and powerful, and they were often asked to publicly or privately demonstrate their power. As I said before, one widespread goal was to find a way to turn abundant metals like lead and copper into gold and silver. The alchemists were more concerned about the transformation, but obviously a wealthy landowner or aristocrat was more interested in the gold and silver. Alchemy is the forerunner of chemistry, pharmacology, physics, and other sciences. It developed tools and techniques that we still use today. In many engravings, you can see flasks and beakers and elaborate glassware that were themselves symbols of alchemistic beliefs. The funnel, mortar and pestle, techniques for separating mixtures and purifying chemicals. A lot of those are still used today. Here you see another engraving with the alchemist kneeling at an altar surrounded by all of his tools. Around 1500, early 1500s, there was a shift away from alchemy in Europe. Kings and New Age scientists began to strive for logical explanations rather than all the philosophical debates that were going on. They wanted proof that certain materials existed. They wanted to know about the forces responsible for life. By the 1700s, reputable scientists were using the scientific method to investigate matter and processes. They needed a logical way to go about proving their theories. The first person to isolate and begin to study oxygen was Joseph Priestley around the 1780s. Antoine and Marie-Anne Lavoisier, they worked with Priestley. In fact, one of the previous slides showed a picture of Priestley and Lavoisier doing some of their gas experiments. Lavoisier also developed the first atomic theory. He was able to isolate and prove the existence of oxygen in air. He developed the theory of respiration, and you can blame him for writing the first modern chem textbook. And he developed a way to measure mass to the nearest gram, I believe. John Dalton, however, is considered to be the father of modern atomic theory. In 1803, John Dalton wrote a paper that included much of what we still believe to be basic atomic theory. All matter is composed of atoms. Atoms cannot be created or destroyed. All atoms of the same element are identical. Different elements have different types of atoms. Chemical reactions occur when atoms are rearranged. Compounds are formed from atoms of their constituent elements. Some of these ideas were actually disproved. Can you think of one or find one on there that we know not to be true now? For example, all atoms of the same element are identical. We know that's not true when we consider isotopes of elements, which we'll talk more about later. Dmitri Mendeleev in 1834, he's considered to be the father of the periodic table of the elements, but there were many people that piggybacked off his work or altered his basic work. The early periodic table that he put together was used to predict the properties of even undiscovered elements, and it was found to be quite accurate. In 1898, J.J. Thomson discovered the electron and developed what became known as the plum pudding model. We'll talk more about how he did that later. In 1909, Ernest Rutherford discovered the protons, and by 1913, Niels Bohr made the first complete atomic model. The Bohr model of the atom survived for over 100 years, but now quantum theory, quantum mechanics has given us a much different view of what an atom really looks like. Chemistry is important because it is involved in so many areas of study and so many different careers. There's organic chemistry, which is carbon-based chemistry. There's inorganic chemistry, which is non-carbon chemistry, which is mostly what we're going to focus on in this class. There's biochemistry, the chemistry of life processes. Analytical chemistry, we're going to do quite a bit of that in here as well. Physical chemistry, all areas that we'll at least touch on this year. Chemistry, basic understanding of chemistry is super important if you're going to go into areas like pharmacology. In biotechnology and most medical fields, chemistry is a requirement. In agriculture, basic knowledge of chemistry could be helpful. Environmental sciences, and even astronomy. You might be a little bit scared to start chemistry, but we're just going to start at the very beginning and we'll get through it.